So now on 3751, the switch that the monitoring station is connected to, conf t, monitor, session. We want to configure a span session, so we use the session command. On this switch, 66 span sessions could be configured. If we wanted to configure span on the 2950 switch, it doesn't support the same number of sessions. On this switch, it only supports 2 sessions. The number of active span sessions, however, is switch dependent. Have a look at the documentation of the switch. Here we'll simply configure session 1 to keep it simple. We need to specify a source as well as a destination of the span session. So the source in our example will be VLAN 1. And I want to capture traffic both sent and received in VLAN 1. You need to be careful spanning a VLAN. If a lot of traffic is transmitted and received on that VLAN, you could oversubscribe the port. As an example, if this switch had 24 ports and you spanned all of those ports to this single interface, you would possibly overwhelm this physical interface. As another example, you don't want to span a gigabit port to a 100 meg port. And in the same way, you need to make sure that your capturing device can handle the traffic that it's receiving. You don't want to, as an example, forward 1 gigabits per second of traffic to a PC with a slow CPU that can't capture or handle the amount of traffic that you're throwing at it. As an analogy, we as people may drink water from a glass or from a tap, but generally not from a fire hydrant, because the rate of water that's sent out of a fire hydrant is far more than you can drink. So don't overload or overwhelm the port as well as the PC by sending too much span traffic out of this port. So now, monitor session. We need to specify the same session number, and we're going to specify a destination. In this case, it's going to be a local interface on the switch, Fast Ethernet 105. I'll talk about the encapsulation and ingress options in a moment. For now, we're just going to forward the traffic out of the port. So do show run pipe include monitor. We configured this command as well as this command on the switch. Show monitor. We can see that we have one active session. It's a local session. It's looking at traffic sent and received on VLAN 1. That's the source. Destination is port Fast Ethernet 105. We're using the native VLAN as the encapsulation. Ingress traffic is disabled. So now, on the capturing PC, we'll filter for ICMP. And let's restart that capture. And on router 1, I'll ping router 2. And notice we can see the traffic, which we weren't able to see before. Here is a source ICMP packet from router 1. Notice the MAC address ending in 01. Going to router 2. It's a unicast. Here are the IP addresses, so 10.1.1 going to 10.1.1.2. It's an echo request. Here's the reply. It's also a unicast frame from router 2 to router 1. Unicast IP addresses, it's a ping reply. Now, if router 1 telnets to router 2 and logs in, we should be able to see that telnet traffic on the capturing device, and we can. So notice as an example, here's some telnet information. I'll scroll down. The router's asking for a password. Here's the password, CISCO. We could also follow the TCP stream, and we'll be able to see the password. In this example, because we are capturing traffic sent and received on the VLAN, we're getting some duplicates. But as an example, if I type enable, password, show run, and look at the running config of that router, if I filter for telnet traffic again, we'll be able to see the line VTY and the password is shown on the line VTY in the running config of the router. So that's the config on the router, and here it's seen in the Wireshark capture. I could once again follow the TCP stream, and I'll see the full configuration of the router as captured on the monitoring station. So what's happening now is when traffic is received or sent on VLAN 1, it's been forwarded out of this port, and the capturing device running Wireshark is able to view the traffic. So what we did is create a monitoring session, monitor session 1, capturing on VLAN 1, and the destination is Fast Ethernet 105. If we remove the monitoring session, so do show run pipe include monitor, we can see that there's no output. In other words, the monitoring session has been removed. Now when we do the capture, and we, for instance, filter for ICMP traffic and ping router 2 from router 1, we don't see any output. So no ICMP traffic is shown. If we filter for telnet, and then telnet to 10.1.1.2, we don't see anything. But if we put the monitoring session back, so monitor session, choose a number 1, and in this case I'll monitor an interface, F103, which is this interface over here, and we'll do both, and then we'll specify a destination of Fast Ethernet 105. What we should see now is once that kicks in, as you can see over there, we are able to see the telnet information. So there's the prompt of router 2, and if I scroll up, we can see the password. So the router is asking for an enable password, and here's the password that I typed, which is Cisco, and then I pressed enter. Once again, if we follow that stream, you can see the password that was typed. So it's as simple as that to create a monitoring session. So show monitor. In this example, we've got session 1, which is a local session, capturing traffic in and out of this port, and it's going to this destination port 105. Encapsulation is native. Ingress traffic is disabled. So let's talk about ingress traffic.